There are two relatively simple types of decision boundaries we should be aware of. One is the linear, and the other is piecewise constant. If the data is linearly separable, there's a linear function of the features that separates the data into two classes. Notice that linear here doesn't necessarily have to mean a line. It does if you're dealing with just two features. For three features, a linear function would give you a plane. And for higher dimensions, it gets harder to explain or picture. Curious what linearly separable data looks like, a quick image search will give you lots. Now it's important to be clear. Data is linearly separable if one linear function is sufficient. So this data set would work because if I draw this line, it separates the two classes. This data set is not linearly separable. It's also possible that we have data that's separable, but not linearly separable. So here's sort of a classic example where one class is inside the circle and another class is outside the circle. There's no way to draw one single line that would separate them. So that's not linearly separable, even though we see it separable with a non-linear boundary. If a feature is important in a classification task, the feature should give us some helpful information in terms of separating the classes of the data. We can usually search for a pattern in terms of the variables by using the Seaborn pair plot command, target set as the hue. I thought it would be helpful to go over some examples of classification data sets, illustrate the concepts that we've just discussed. Please note that these are toy data sets that are designed just to help you gain intuition. Typical real-world data sets are going to be far more involved than the first example. We have two features. Both features are important, and linear separability is extremely high. If I create the data and I do a scatter plot, which is color-coded by the target, I hope you can see that there is a clear line that would separate these based on the variables x1 and x2. So this data set is linearly separable, and both features are important or helpful to predicting target. Another way to visually determine how useful a variable is to look at the histograms or the distribution plots. So if you look, for instance, at a box plot of the target of the distributions for the 0 value of the target and the 1 value of the target, you'll see here that about 50% of the 0 target data is above all the 1 target data with respect to the x1 value. It tells us that x1 is a helpful variable for separating the 0 class from the 1 class. And that's another thing we can look for as we visualize the data. We can see that same relationship in terms of a histogram using the Seaborn displot command. Again, we see that at this value somewhere in the middle does a good job of separating the zeros from the 1. I can also do what's called a KDE plot, which is basically just like a smoothed histogram. It attempts to draw a curve, smooths out the histogram, then gives it more of a probability distribution look. Change that just by adding kind equals KDE, and then I think these are more helpful if I change fill to be true. But you're seeing the same thing in all of these plots. There is a way to separate based on the value of x1. In my next example, there are 4 features. All 4 features give helpful information, and linear separability is high. So you see in the pair plot similar relationships. You see dividing lines that help separate most of the data based on the histogram, and you see places where drawing a line would do a good job of separating the classes. For the next example, there are 6 features, but only 3 of the features are helpful. The others are just completely irrelevant noise. With respect to the helpful features, the data is linearly separable, but I'm sorry, there's 2 of the features are helpful. My apologies. 2 of the features are helpful, and with respect to those 2 helpful features, so let's see if you look at this, can you see which features is this data linearly separable with respect to? So this data is linearly separable with respect to x1 and x2. On the x1, x2 plot, there's a line that separates the orange from the blue, and you do not see that relationship on the other plots. On the other plot, this just looks like noise, and you would not expect to be able to draw a line that separates. Now, in looking at this, x2 is really the important factor, because x2 does such a good job of separating the data that the it shows up in the other plots as well. So x2 basically separates the data no matter what variable you pair it with. If you look at a combination of two features that don't contribute a lot of information, like x4 and x5, there's really no way to separate these. If you look at two unhelpful features, the plots just look like noise. You don't see any way to separate these based on what you're looking